Greetings and welcome, friends. Mr. Waddy here. We're taking a look at last night's quest. We were talking about two new means to prove triangles congruent, both related to two angles and a side. So we had angle, angle, side, as well as angle, side, angle. So decide whether there's enough information given to prove that the triangles are congruent. If so, state the theorem you would use. So for question 3 here, I've got some given information. I've got these two angles are congruent. I've got angle B and angle R congruent, and I've got two sides congruent. Is there sufficient information to prove these congruent? Thoughts? I'm getting a yes and a thumbs up, a head nod. I'm seeing yes. And what theorem would you use? Angle, angle, side, because this side is one of the non-included sides of these triangles, right? The included side would have been this one and this one. So yes, angle, angle, side works. How about for this one? Wait a minute, I don't have enough information here. I've got like 1.5 pairs of angles. What do we do? Is there enough information? Someone knows something else we can say about this that's true? Josh. Yeah, congruent to itself by reflexive property. That's helpful information. I agree. Right, so there we've got that. Since this is perpendicular, BC is perpendicular to AD, I could say that this is a right angle and this is a right angle by def of right angles, and then they are congruent by right angles congruence theorem, right? So I've got, let's see, angles, angles, and side. I think we have enough information. So the triangles are congruent by angle, angle, side is what we needed. Right, so these ones were just far simpler. They didn't require a full formal proof. All right, questions 7 and 8. I like these ones. They said, what additional information would I need in order to use the angle side angle congruence theorem? So let's label the information they've given us. So I've got FG is congruent to LM. I've got angle G is congruent to angle M. And I'm shooting for angle side angle, so I believe I'll have limited possibilities. It looks like I need another angle because I've got an angle and a side already. What other angle do I need to relate? Tyler. Angle F is congruent to angle L. Yep, because the side is in between the two angles here, so the side needs to be in between the two angles, right? Included side. Let's check out some more interesting problems here. So, okay, here we go with the proof. So I'm going to have the given information, right, as usual, right, for my statements and reasons. Let's see, what other information do I have? I've got some perpendicularity. I could say that angle N. Oh, man, I can't just call this angle M, can I? I've got to give it its proper first, middle, last initial for its name. So I guess I'll do the same thing for angle N. QNM and angle PML are right angles. All right, right angles. And that is true by def of perpendicular lines. Right. And since they are right angles, I believe we can claim their congruence. So angle QNM is going to be congruent to angle PML by right angle congruence theorem. Right angle congruence theorem, THM. So now that I've got these two angles congruent, what else do I have? Let's see, M is the midpoint. What fact does that give me? How does that help me? And M is congruent to ML. Reason? Def of MP. Right. So these are congruent, and I've got some parallel lines. Do those help me in any way? Which angles do those relate for me? I could relate this one to this one by alternate interior, but this one's not even inside of one of my triangles. No, I can't hit those. What about these two angles? What types of angles are these two with respect to the parallel lines? They are acute. What's their relationship to each other? They're corresponding angles. So by corresponding angles theorem, I could say QMN is congruent to angle PLM. Well, the transversal happened to be this. Yeah, so it's kind of like you really got to kind of like visualize what the transversal is at play. Yeah, but those are corresponding angles. And I believe I've got pair of angles, and their included sides. So I'm going to say triangles are congruent by side. Nope. Angle, side, angle. There we go with the save. And let's see if I can I guess we'll just use theirs. So NQM is got to be congruent to MPL. And make sure you guys are aware of your naming conventions. There are 6 different ways of naming any given triangle. But once I'm declaring congruence, I need to make sure their corresponding parts line up. So triangle MPL. All right, last proof. Here we go. I might be able to show you the answers for the other proofs off the air as well, in case you guys do want to see that. All right, this one, I like this one a lot. I was actually looking at this, and I was going to try to make a statement about like these sides using some sort of segment addition postulate, but that is not what we need to do. Let me draw these triangles as 2 separate triangles, maybe. I think that sometimes can be helpful. So imagine these were congruent to one another. Let's see if I can even name these correctly. Z and the dubs and the U. Ooh, W single U right there, represent. And let's see, that is not an X, that's a V and a W. So let's see what I have labeled here. I know that this is congruent to that. I know that this little angle is congruent to that angle. What is another fact that I can state? So I've got my givens. What are you thinking, Josh? These ones. That is true. Actually, let's double check which triangles we're working with. X, W, V. So we're working with the bigger triangles, of which that is a true statement, but I don't think it'll be directly helpful. Unless maybe you're working some other angle that I don't know of, because that's not one of the angles of the vertices of the triangle. But that is true. That is true. Someone notice something else that we could use? Yeah. Congruent to itself, classic reflexive, right? Sometimes it's just like a matter of like visualizing and being able to see how these come together. Whoop, whoop. And dubs to the dubs. And actually in all 3 of my sketches, W is a unique enough angle that I don't have to give it its proper full 3 initial name. And I think I've got enough to prove triangles congruent. So I'm going to say triangle XWV is congruent to triangle. Let's see. So XWV. So I'm going to need ZWU, and that is what they had as well. And the reason, angle side, right? Because the side is not included. So angle, side. All right, thanks for watching, Internet friends. Tienen un día más bien del mundo.